This time we're going to make a foam. So this is a polyurethane system, and the way they actually make foams is to add water to the polyurethane, and it reacts with the raw materials and makes bubbles, and that's how you make a foam. So we have some green food coloring, which has water in it, and I think this will be enough water to make this urethane foam. So let's give it a try. This is a 1-to-1 system, so I need equal amounts of the resin and the hardener. Okay, so we'll put 1 shot of the hardener in here. And we want to use the hardener side to add the pigment to, because the resin side, as being the reactive side, if I put the water in there, it's going to start reacting and I might not have time to work with it properly. So we'll put a couple drops in here because we want to see the foam reaction. Just to make sure. All right, we'll stir that in a little bit. Makes a really dark green liquid. All right, I'm going to take an equal amount of the resin. Squirt that in there, and let's see what happens. So I'm going to start mixing it up here. Gets a little bit lighter in color because I've now diluted it. And I'm going to give it a stir. Now this is an exothermic reaction, so it is again going to be giving off heat as it reacts. All right. And now if you can see, it's actually bubbling. It's going to bubble right up and bubble right over this cup. So I definitely can't do the same kind of thing that I did the first time. Oh, there we go. But that's how you make foam. So now I have this nice big cup of green foam. Now, again, being an exothermic reaction, this cup is getting very warm from all that heat and all that material that reacted. I mean, it went very quickly from a liquid to a solid, you can see. But that's how they make foams. This is a slightly different material than an epoxy, but it's very similar in properties and performance and the way you use it. This is actually a polyurethane, but it's very fast curing and it's a very interesting little demonstration. So what I'm going to do is I'm going to turn liquids into a solid right before your eyes. So this is a 1-to-1 system again, so we want equal parts to mix and to work with. So this is the resin side and this is the hardener side, and so I'm going to squirt some of both into my mixing container. I'm going to take about 20 mils of each. Okay, there's my hardener. I'm going to do the same thing with my resin. And here. Okay. So there I've put equal amounts of material into my container, and now I'm going to start mixing it. And as I first start mixing it, it's just going to mix, and it's kind of an opaque brown, not really interesting, doesn't really do anything. As you stir it, it's going to start changing color. It's going to start heating up. So as I mix this in my hands, I will actually at some point start to feel heat being given off. This is an exothermic reaction. So these are liquids, and if you think of water, water is a very small molecule. Well, what's happening is I'm taking small molecules of this resin and this resin, and they're combining. So bonds are being broken, bonds are being formed, molecular weight is being built, and these molecules are adding together in such a way that they will, in theory, turn into one giant molecule. Now I can feel the container starting to warm up, and so I'm going to keep mixing it. I really need my pan. There we go. Okay. So I'll set this over here, this over here. So what I'm going to do is actually make this container stand up on its own with this resin that's curing in it. So it's starting to get really warm, it's thickening up. So I want to start to do some stuff here. I'm going to pour a little bit of material because I want it to make a base that I can stand on. And you can see how the material is getting quite thick now. It's not a liquid like water, and it's thickening up and thickening up and thickening up to the point where it stops flowing. Now in theory, at this point, this is almost one molecule, one giant molecule. All this stuff is added together, and you can see it's cured and it's stiff. Now, as I said, it's an exothermic reaction. It's giving off heat. So this is also very warm. So this is actually a little bit rubbery. But if I hold it, you can see that the material is strong enough to suspend the cup in the middle of the air, and as this cools and stiffens up, it'll actually be able to stand on its own like that. Or like that. Well, not going to stand up. But that's a very quick polymer reaction.